Alright, so like Ashley just said, my name's Feucht.
I'm James Foley.
Andy Jenkins.
And we did an analysis of Beaver Creek water quality, or Beaver Creek Reservoir water quality, and the effect that it may or may not have on Star Hill Brewery product quality. And the reason why this was interesting to us is because, what college student doesn't want to study beer for 3 semesters? Additionally, it has a really important social context because not only does Star Hill use the water from Beaver Creek Reservoir, but so does the entire community of Crozet. So any effect that may be seen in the reservoir from the weather will not only be seen at Star Hill Brewery, but in the community of Crozet itself.
So just an overview of what we're going to cover today. First, with our introduction, we'll be looking at the Beaver Creek Reservoir and the brewing process. Then we'll go into our methodology and results, where we'll talk about our data collection and instrumentation, and the water quality in the brewing process, and the data assimilation and data analysis. Then finally, we'll have our conclusions, recommendations, and acknowledgments. So to start off, what is a craft brewery? Well, the American Brewers Association defines a craft brewery as small, independent, and traditional, and it must also have a production size of less than 6 million U.S. beer barrels per year. And we chose Star Hill because it was local and rapidly growing, and we also wanted to continue a senior project that was done with them last year, but this time we wanted to bring in more of the environmental science side of things. So why is water quality so important in beer? Well, water is the main ingredient in beer. It takes up approximately 90 to 95% of the beer. And so the changes in the water chemistry ultimately affect the beer chemistry, which can affect the final taste and quality of the product. So Beaver Creek Reservoir is actually where Star Hill pulls their water from. It's about 5 minutes down the road from the actual brewery. And it's actually located in Albemarle County in the Rivanna watershed, and the reservoir itself is 104 acres. And it was actually placed on the impaired waters list in 2006 due to a pH impairment. And the impaired waters list is basically a list of the waters in a state that doesn't meet the state's water quality standards that they have to send to the EPA every year or 4 years. So the total impaired size was 95.54 acres, most of the reservoir. And the main source of the pH impairment was the atmospheric deposition, which is basically the rain falls and collects the pollutants from the atmosphere and then deposits them on the ground or in the water. So the watershed derives a lot of its drainage from the Shenandoah National Park. So there's several relatively pristine headwater streams and other river segments in the watershed. But however, due to development and land use pressures, both rural and urban, there's many other streams that are not as healthy and in many cases do not meet the Virginia water quality standards. So looking at the land use of the watershed itself, 72.2% of the watershed is covered with forest, 22.8% is open land, 3.2% is impervious surface, and the remaining 2% is water, orchard, and golf courses. And the creeks and tributaries of the watershed are subject to very high peak flood flows, and with continuing urbanization and expansion of impervious surfaces, the flow potential is continually increasing, therefore bringing more runoff into the reservoir and affecting the water quality. And this is just a picture we took from one of our sampling sites, the Dock 1, over by the dam of the reservoir. This was taken in January, I think.
All right. Like Mandy said, Star Hill Brewery pulls its water from Beaver Creek Reservoir, but before it gets to the brewery, it has to be treated in a water treatment facility. And it's kind of an extensive process, but basically the water is filtered over and over, and chemicals are added to help clean and filter the water. Chlorine is a good example. It's added to kill potentially harmful microorganisms and other bacteria. But after the water treatment process is complete, it comes into the brewery and the brewing process starts up. So your 4 main ingredients for brewing beer are yeast, water, and a source of starch such as barley, and any additional flavorings you want to add, like hops, for example. There's 9 main steps: malting, milling, mashing, lautering, boiling, fermenting, conditioning, filtering, and packaging. In malting, water is added to the barley and allowed to soak for a few days, and then it starts to germinate for a couple days after that, and it just sits there and dries up. After that, it goes on to the milling stage. In milling, the malt is broken up a little bit to make the carbohydrates and sugars inside more accessible. Following milling is mashing, where water is again added to the mix, added to the recently milled malt, and it starts to turn into sugars. After that, we have lautering, where the wort is strained from the rest of the mix, the mash. You don't really need the solid stuff left over, just the wort. And then the wort is boiled in order to sterilize and to end any processes that could be occurring if germination is still going. After the wort has been boiled and cooled down, the wort is put into a fermentation tank where yeast is added. The yeast starts the fermentation process, and that's when the wort is officially beer. The fermentation process takes a few weeks, and then it's conditioned, where it just sits there, and conditioning can take weeks to months depending on the type of beer. After conditioning, the beer is filtered. It's not a necessary step depending on the type of beer, and then it's finally packaged up and sent out. So data collection. We had 4 main testing sites, 2 at the reservoir and 2 at the brewery. The first dock, like Manny said, was located towards the middle of the reservoir where there was deeper water. And the second was on the edge of the water, where we hoped we'd get different results with more runoff. We attempted to sample weekly, but as you all know, it's been pretty insane with the weather, and we couldn't always travel over the mountains in the snow. So we ended up with 6 sets of samples, and we pulled our weather data from the National Climatic Data Center archives online, and we got our Star Hill product quality data for each of the different beers from their fermentation logs. The data was pulled anywhere from the beginning of December to the end of March, and we initially had considered a 5th sample, jetter water, but every time we went to get samples, they were always bottling, and the sample was located in the packaging line, so we couldn't always grab data for that. Okay, instrumentation. So the WTW kit is equipped with different probes for measuring pH, dissolved oxygen, and conductivity. And the hardness kit is obviously used for testing hardness. It's just a basic titration, and it takes magnesium and calcium into account for total hardness. And then we have the ion chromatography process. It's used for measuring many different parameters, such as chloride, fluoride, bromide, nitrate, sulfate, and phosphate. But we were only curious about the chlorine levels. It separates the molecules or anions based on charge, and it injects our samples into the machine, and they run through a pressurized column. Liquid known as eluent is also put in the column to start drawing out the ions. You can figure out what's in your sample based on the retention time. Chlorine, for example, has a known retention time of about 3 minutes, so anything coming through the column at that time is chlorine. We also had the atomic absorption spectroscopy process for our iron samples, but again, we weren't able to use those in our analysis.